Welcome to the water management video for the house located here at 3612 Ida Bell Lane. My name's Nathan, I'm one of the builders of this project, and you're watching what's part of an overall series of videos explaining the different details of construction that we incorporated here to result in a little bit higher performing building than average, and certainly higher performing than houses of the past. This one's about water management, and I want you to understand that the water management approach that we took to this building, which honestly we feel should be taken with every building that's built nowadays, was intentionally elevated above average to be proportionate to the rest of the performance features that we've put into this place. If you watched the introductory video, you heard me talk about how airtight this building is and how well insulated it is. And when you do that stuff, you lower the drying potential of the insides of the assemblies, of the roof, of the walls, and what have you. And so because there's less forgiveness inside the wall, you have to build your forgiveness on drying into the outside of the building. And so this video is going to kind of take you through some of the details that we did to accomplish that. So the whole idea here is that the whole building is a big system, and each component of that system has to take the others into account to be balanced and harmonized with them so that the whole system works. And so let's talk about the way that we did that with water management here on this house. Now, we're going to start from the top, move our way down to sort of trace the path that water is going to encounter this building through. And when it comes to the roof system, up there at the very lid of the building, very conventional. It's a simple roof shape, mainly one big gable with another little gable over there at the other end. Not a lot to get wrong here. We have asphalt shingles and synthetic underlayment, very, very comparable to pretty much every other roof in the Chattanooga area. Now, when we come down to the edge of the roof, we put a nice, generous overhang on this house. It's about 2 feet wide. We went as far as we could with the overhang without going so far to trigger complicated and expensive structural stuff once you start moving that roof, so far away from the side of the wall. And the reason for that is very simple. If you can imagine standing outside in a rainstorm, you've probably done that with one of those small foldable pocket-sized umbrellas, and you've probably done that with one of those big golf umbrellas at some point in your life as well. And when I say all that, you start to clue into the difference between those things, and you're probably already understanding what the purpose of this overhang is. The further away from the wall that you send that drip line, the better protected that wall is going to be, and the shorter down toward the base of that wall that wetting profile is going to be from the splashback, and the less water can trickle down from above. So that right there is a pretty huge, easy, obvious thing that's really easy to do in new construction to give the maximum amount of protection to the house. Because, for example, this window, if it's going to leak, it's probably going to leak at the head. That's where many window installations fail. Well, that head is so close to that overhang that it will probably never get wet in the first place. If it can't get wet, it can't fail. The most exposure that we have for our windows is over here on the end of the house with the bedrooms, where we have that big rake wall at the end of the gable. And they are a little further away from that overhang. But we'll talk about the way that we flashed these things, which will help you feel good about the water protection strategy that we have on those in a later portion of this video. The thing I want to focus on right now is the exterior doors, which are pretty much all protected by really generous roofs. So the two on the back porch, probably never going to get wet. They're under the back porch. The front porch has like 8 feet or so of roof projecting beyond that door opening. And then even over here on the side porch, which you saw in the beginning of the video, we've got a pretty generous sized stoop protecting this whole door right here. And that was all intentionally designed around water management. Because if a door is going to fail, it'll fail like a window at the head, or they can also sometimes take on water at the sill. Well, none of those locations should ever see any meaningful amount of water in the first place. And so that was strategy number 1 when it came to protection for that stuff. And then strategy number 2 is the flashing, which, as I mentioned, we'll get to in a minute. As I make my way around the house here, one more thing I want to draw your attention to is right up here where this roof line meets this wall. Kind of hard to see, but there's a little piece of metal sticking up right there. And if you look at the pictures that I'll drop in here, you'll see that that is a little angled piece of flashing that angles away from the side of the wall. When you're roofing a house and you have this condition where a roof meets the side of a wall, you have these little right angle pieces of metal that, cap the edges of each shingle course that dies into the wall. That's called step flashing. And it's designed to catch water coming down from here and send it away from that wall so that it doesn't get down into the joint between the roof and that wall, right? Well, oftentimes you don't see that terminated right because it's just one last piece of step flashing at the very end of the run. It's supposed to have that kick out flashing. And the kick out flashing is designed to move the water away from the wall at the very end so that it can all drop into the gutter. If you didn't have that, many times, and I'm not saying that it happens all the time, but it is frequent enough that that step flashing will actually let water get behind the siding. And in this case, that could be potentially catastrophic because if we had water get behind the siding up at that location, it's going to come down here and it will encounter the flat piece of trim on the underside of this beam. And that's a 2-ply beam that penetrates to the interior of our wall assembly. So if we were to somehow let water behind the siding there, we have the potential for it to get inside the house. That's a huge, huge problem, but we're protected here by that little 10-cent piece of metal that's going to save us hundreds or thousands of dollars of future repairs. Very important there. Above the step flashing along this area, we have a counter flashing, and that's just another piece of metal that laps over the top edge of the step flashing. Now, if we have water trickling down the wall behind our siding, if that step flashing is just kind of bare at the top edge, it could find its way behind the step flashing. So one thing you could do is tape that step flashing to the wall so that water that's coming down has to get in front of it. Well, at some point this house is going to need a new roof. And when the roofers come, they're going to take that old step flashing out and put a new piece in. Well, now you have an untaped top of the new step flashing because we know they're not going to pull the siding off to get to that top edge. Well, that's where the counter flashing comes in. It's a second piece of metal that laps over the top edge of that stuff, and it is positively flashed at the top to the wall sheathing so that any water trickling down the wall meets that flashing tape, gets in front of the counter flashing, which then sends it in front of the step flashing, which sends it in front of the shingles, which sends it to the kick out flashing into the gutter, down the downspout, and away to the front yard. Sweet. We've given it a path. We've given it a clear order of steps to get away from the house with that counter flashing. And that's going to future-proof you because when that step flashing gets replaced in the future, all they've got to do is tuck it up behind there and you are protected once again. So that's really great. Now, as if that weren't enough, here and also in the little side entry porch where that other roof line hits the side of the wall on the other end of the house, we pre-flashed that with a piece of really high quality tape that connects the roof deck to the wall sheathing so that even if there were an imperfection or a failure in that step flashing or that counter flashing, there's another layer of protection there to keep water from being able to get between the wall and that roof deck and down into the primary suite or down into the laundry room. So that's what we did about all that. Now, as we come down the walls, as I make my way kind of across this side of the house, I want to point out all of the penetrations right here and just kind of talk about the gaskets that we used for a moment. We've got, utility services here and so forth. And anywhere you've got a hole punched in your wall system, you've got a potential leak. And so the way that we handled that here was with a gasket that we found that's made of EPDM rubber. That's the same stuff that rubber roofs are made of. And it's got holes pre-punched from the factory of varying sizes for different size lines that you want to waterproof with it. And in some cases, it's actually integrated with a really high quality flashing tape around the edges so that all you've got to do is pop that thing over that line, seal that tape to your wall, and you are waterproof and airtight in one step. Something else I think is really cool about that is that that rubber allows for repositioning of the line. It hugs it really, really tight, but it doesn't stick to it. And so you can reposition or even completely remove and replace the line that passes through it while not losing that water and airtight seal. And that's really great because the serviceability for the future is there, the repositioned ability for repairs is there, and you're not going to have a problem with your water or air management because of those gaskets wherever you have these utility penetrations. Now, what are those sealed to? Let's talk about the wall system now from our waterproofing standpoints. We have Huber zip system sheathing on this house. That's the flat green board with the black tape all around the panels that you've probably seen in other houses going up in our area. That's a bit of an upgrade over the, I guess, the cheap approach, which would be bare OSB sheathing with a cheap house wrap stapled around it. We wanted that, again, because of the superior water management that provides. That green coating is a really robust waterproof layer that's applied at the factory. And then once you tape it all together with their flashing tape, you are waterproof and airtight for the life of a building. That flashing tape is really, really effective. Well, you can learn more about that in other people's videos online. I won't get into the details here, but suffice it to say here that it's a really, really good system. And we were really pleased with the way it came together here. Now, when it comes to our window and door openings, we wanted to make sure that we paid some special attention to those, because that's an area that, even with other homes that may have zip system sheathing, sometimes that waterproofing around the openings isn't always done very well. And so what we did here is like this. Wherever we have a window or a door opening in our wall, we have a sill pan. That's just a technical term for a waterproof layer all along the bottom of that opening. And we made ours out of tape. Again, their flashing tape is really good for that stuff. The regular stuff is excellent for flat surfaces and right angles. But down here in the corners, that gets tricky because of all that, several angles kind of coming together. So we used their stretch tape there, which is a chunkier tape. It's got a really aggressive adhesive on it, and it stretches and conforms to complex geometry like that for a completely monolithic waterproof pan at the base of all the window and door openings of the house. We also lined all of the openings with their flashing tape as well before the windows and doors went in. And that's more water protection, and it's a bit of an air seal detail too, which we'll get to in a different video. But all that to say, before the windows went in, those openings were protected, which means that if water gets around the window or behind the window or whatever the case may be, it can only touch a waterproof surface. It cannot touch any sensitive wood surfaces because they've all been protected before the windows were installed. Now, after the windows were installed, standard practice being to tape with more of that flashing tape around the top and the sides. So what we did here, we did not tape the bottom. You may have seen other houses being built with the bottoms of the windows taped, and you may wonder, like, well, why wouldn't you tape the bottom? I mean, if you're taping everything else. And the reason is that, water is typically traveling downward, okay? So you want to give it a way to go. If you're open on the top and sides, you have an opportunity for it to get in. But if you're taped at the bottom, you do not have an opportunity for it to get out. So we tape the top and the sides, but we leave the bottom open for drainage, just in case any amount of water were to ever get inside that assembly somehow, it has an opportunity to escape. If it camps out for a while, when water gets wet and stays wet somewhere it shouldn't be, is when you get problems. So this way we have a pathway out. We have an air seal around the inside of all of these windows and doors, but we have a water seal at the top and sides and a drainage opportunity at the base, okay? So that's how we handled all that. Now, when it comes to the siding, we have this beautiful board and batten siding along the front of the house. And something to say about that is that it's wishful thinking to think that the siding is going to be waterproof. It's going to do most of the heavy lifting. I mean, it has to. It's the outermost layer. It's going to experience the most water of any part of this, other than the roof. But there's always going to be some amount of water that can make it back there. And we've got a plan for that here. So we talked about the zip system sheathing. We talked about all the gaskets and flashings and things that we did. And what all that kind of indicates is that we're considering our primary water control layer to be behind the siding, okay? Now, when you have board and batten in this day and age, it's not actual boards. It's big flat panels. And then the batten strips are just these kind of decorative things to kind of mimic the way that you would have covered the joints between actual boards in the past, like on all old barns and stuff. So we have a 4 foot by 10 foot flat panel nailed to the wall with these batten strips in front of it. Now, if we were to just put a big flat panel in contact with another flat panel, and we didn't trust the first flat panel to be completely waterproof, and we were asking our second flat panel to do that for us, well, if any water got behind the first panel and it was in full surface area contact with the second, it would have a really hard time escaping, wouldn't it? Well, we've got a plan for that here, like I said, and it takes the form of an entangled mesh product that provides a spacing between the board and batten panel and the wall sheathing. That spacing is about 1/4 of an inch, and it's uniform throughout the entire wall for a really flat finish, and it allows for drainage for any water that might otherwise find its way behind our siding. And so that's what we did with all that. Now, in the sides and back of the house where we have our lap siding, we're less concerned about that there, because that lap siding profile creates a series of little triangular air spaces behind it. And that air gap is, we feel, protection enough for water management in those areas, especially considering the way that siding is shingle lapped to provide, drainage to the outside everywhere. But it was where these panels are so flat and otherwise in contact with that wall that we wanted that drainage space. So the overall strategy really had to do with kind of focusing our time and our resources in the areas where they really mattered. And so that's the strategy that we took there. Now, looking behind me here on the front porch, bringing our focus to the natural wood product that we have on the front wall here, we took a similar approach to that. Being that it's actual natural wood in an exterior application like this, we wanted to do everything we could to protect it as well for the best possible longevity and beauty over the years. So, we're underneath this big, pretty roof. So the actual wetting potential for this wall is almost nothing. We have seen a little bit of wetting, like some splash here in this lower corner, only because of the, a little bit more exposure from the open roof above there. So I'm not really concerned about bulk water in this wall, but I am a little concerned about outwardly driven water vapor in the wintertime. And so being a natural wood product, I live in a 1920s home with all natural wood siding, and I've seen several of my neighbors' homes paint failure early, siding degradation as, those older homes have been retrofitted with insulation over the years. And so we put a ventilation gap behind this wood here just to protect against similar dynamics in this house and really get that wood to last as long as it possibly can. Rather than the mesh stuff that we used everywhere else, we just have spacer strips behind this stuff, but those spacer strips had to be oriented horizontally because of the way that the wood here is oriented vertically. Now, a solid spacer strip material would have blocked drainage, and it would have blocked ventilation airflow. And so the spacer strip that we used here consists of it's like the same stuff that they make those campaign signs out of that you see stuck in the ground at street corners and stuff. It's got these sort of fluted channels through the middle of it. And so we oriented that stuff horizontally with the channels oriented vertically so that we preserve that drainage and that ventilation airflow behind this wood while being able to still provide that spacing off of the sheathing. So that's a pretty cool detail that we were able to handle there. Okay, so we talked about the roof, we talked about the walls and the flashing and the openings and all that. Let's talk about drainage. So we have our gutter downspouts all piped into solid pipe. All those solid pipes are collected. Let's see, there's one there behind me. They're all collected, and they daylight to 2 points, one half of the house over here, one half of the house over there. And there is one of them. So these things move a ton of water. And it was important to us to use the solid PVC for this stuff because of how smooth it is on the inside and how well it flows and how non-susceptible it is to getting clogged. We did not use that black corrugated plastic stuff on purpose here because of the way it can clog so easily. We've just seen too many failures of that stuff. It crushes really easily, it clogs really easily, it fails way too fast. So we spent just a couple of extra bucks for solid pipe here, and we're really glad we did because it moves a ton of water. So that's doing the lion's share of the drainage for the foundation by carrying the roof runoff away from the house before it can even get down to the foundation. The ground is also pitched away from the house all the way around, including in the back there where you have that big slope coming in from the neighbor's yard. The ground up against the house is actually pitched away from the house there, and then we made sure to pitch it to either side to create some drainage pathways for the groundwater that would otherwise try to run up against the house. So between the underground drains for the downspouts and the grading around the house, we're handling probably 95 to 98 or 99% of the water that would otherwise want to challenge that foundation. Well, the other 1 to 5%, however much it may be, is handled by an underground foundation drain. All around the perimeter of this house, we have a trench around the foundation that goes right down to the footing level. And that trench is filled with a French drain. That French drain consists of a layer of filter fabric to keep the dirt and the sediment out, a little bit of gravel, and then a PVC pipe that's perforated on the bottom. And those perforations along the belly of that pipe give the water that might otherwise collect at the base of that foundation an opportunity to get into that pipe, where we then send it across the sides of the house and out into the front yard. And that's what the other pipe here is beside me. One's the downspout, one's the foundation drain. We filled the rest of that trench with gravel, and then we wrapped that filter fabric up over the top of that before backfill, so that we have a very free draining, clear draining system all the way around the parts of the house that need it, that are protected from sediment buildup and so forth. And I tell you, it's really effective. We did that early in construction on purpose, before we had our roof and downspout drains in. And I tell you, it moved so much water away from the foundation during construction. Now that we have the downspouts on and everything, it's down to like just a bare trickle. But I'm still comforted by that, because that trickle coming out of that foundation drain means that we're collecting any remaining water that might otherwise challenge our foundation, and we're giving it somewhere to go, and we're not letting it sit up against the house. That's really important for keeping that crawl space dry. That's really important for protecting the foundation of the house for years to come. So that concludes all of the water management strategies that we pursued here. Everything that I've mentioned, I've tried to highlight the stuff that's different, or maybe over and above what's normal for our area, so that you can understand that you're getting something that's been really well thought through and really well executed for the best possible protection of your home. If you have any questions, glad to get into that with you. Check out the other videos in the series for more information on the other parts of the building as a system that we've done here, so that you can really understand what you're looking at here. If you've made it this far, thanks for watching. We'll see you in another video.